So next topic is very basic and at the same time very important. Without units, you cannot think for designing or installation or estimation or this drafting. Okay. So as an engineer, this is like a MS Office for you. So MS Office is a very basic in all the fields. So this without units, you cannot think to deal with the calculation part. So first of all, we'll discuss what is units. Then the system of measurement like SI, metric, and English. Then we'll talk about the conversion in detail. Okay. So you see, as an engineer, you're already aware of this units, conversions, and the system of measurement, etc. But here we'll discuss the application side, how it is used in actual practice. Because you see, this course is not academic course. No? After this, you're going to implement in actual practice. So try to understand the application side of this. So we'll discuss in that way. So let me read for this unit first. You see, concepts such as length, area, volume, temperature, or you can consider flow rate or time or velocity, etc. are called physical characteristics. Can you agree with this? Do you agree with this? Length is a physical characteristic. Means length we can measure physically, no? Area we can measure physically, volume, temperature. These are all physical characteristics. And physical characteristics are measured by a standard quantity called units. For example, first of all, we'll try to understand the importance of this. So first point is what? Concepts such as length, area, volume called physical characteristics, and the physical characteristics are measured by a standard quantity called units. So what exactly? For example, if I write say 90 is what?
It's a number.
It's a number. Okay, it can be length, or it can be area, or it can be your age, or it can be anything, or it can be a currency or rupees, etc. So this we can call as a magnitude. And magnitude required the unit, then only it will become a physical characteristics, or it will get the physical characteristics. Okay, this without this unit, the magnitude, we don't have any what I can say, any physical characteristics. Na? For example, if I write 90 this meter, now it is a length, right? So remember, this meter is a unit and this 90 is a magnitude, and this combined will get a sense or will get value. Okay, simply 90 means it can be anything. So getting my point online?
Yes.
I'll give you one more example to understand the importance of units. In the starting session, I think you remember, we discussed the standard temperature for human comfort. We discussed this thermal comfort, na, ashtray 55, ashtray standard 55, and I have given the table also. In there you'll find the different temperature. So assume that the standard temperature for human comfort is what? 76 what?
Degree Fahrenheit.
But by mistake, if I write 76 degrees centigrade, then
it's a horrible case.
yeah, people will die. You see, even we cannot resist 60 degrees centigrade, which is a hot water from the geyser. In the bathroom, the standard temperature for hot water is a 60, and the directly hot water we cannot use. Mixing is required. 76 degrees centigrade. It's a horrible condition. The people will die in this. So if I write that makes sense. This is a standard temperature. Nothing but this, say 24 degree centigrade. If you just convert roughly. Okay. Similarly, if I write say 10,000 INR compared with 10,000 say dollar, both are same or different? How many? 80 times or 82 times, roughly say 80 times. Okay, so this unit will change the complete sense of that particular magnitude. And why I'm explaining this? Because you see, if you are working as a design engineer, by mistake, instead of 76 degree Fahrenheit, if you write 76 degree centigrade, or by mistake, this instead of say 1000 CFM, if you just add say 1000 this cubic meter per hour, what will happen? The entire quantity will change as a design engineer. Similarly, if you're working on site and if you want to install a duct of say 10 meters, but by mistake you fabricate as 10 feet, so you're reducing that quantity to almost 3.28 times less. And especially if you are a estimation engineer, and if you just extract the quantity, estimation engineer means metal takeoff. So there's the role of a estimation engineer means he must extract the metal, then only the procurement people or the company can purchase and they can deliver on site. So if they do mistake in that quantity, then that will affect the whole project. Na? And remember, for standard or for international, for big projects, will place the metal from other countries also, because all the metal will not available in one location. So they may place the special pipes or special equipments from other countries, and it may take some time, 3 months or 6 months to deliver on site. In that case, if the estimation engineer did the mistake, then it will affect to the whole system or whole project, because delay in one service will affect to all the services. So that's the reason this units are very important. Units and the conversion. Okay, so I think you got the idea of the importance of the units. Can I proceed to the next option? You see why I'm
Yes.
explaining and why I'm focusing on this, because these things are very important and people are not focusing on this, and that's the reason they're getting a lot of confusion. Even I saw experienced people also, they're getting confusion in the conversion in units, etc. And this confusion happened because of lack of visualization. Okay, so you need to visualize, and how to visualize, I'll give you the idea. So you see, a unit is a measurement and it's a standard quantity that serves as a reference. For what? For expressing the magnitude. Magnitude means that number for a particular physical quantity. So I've given a lot of theory. You can go through once after the session. So I'll just focus on the concept. Okay, the main points. Additional points also I've given. This time I've given some more additional theory for the units because this is important. So I think got the idea what is unit and then the importance of the units. Now we'll talk about the system of measurements. So if you talk about the system of measurement, you'll find FPS, CGS, MKS, what you learn in the intermediate or in the physics. So we'll not bother about all. So we'll discuss as per the present world or as per the industry requirement. So if you talk about the industry, say HVAC industry or say construction industry, because this is not only for HVAC, this unit is for entire construction industry. Mostly you'll find this two system of measurement. One is a SI. SI in short, we used to call that's the international system of units. And do you know the source of SI online? Do you know the source of this SI units? The source of the SI unit is a metric. Okay, so actually SI and SI is a part of the metric, but how exactly I'll explain. So one is a SI, international system of units, commonly used in present world in almost all the countries except few countries. And the second measurement system, and the second measurement system is English system, also known as imperial or IP. So you see, we don't have the fixed option in actual practice. Say everyone is using international system of units only. As per the requirement, we are using the mix option also. We'll conclude that, but first of all, we'll talk about SI. So SI is what? Is the international system of units, which is globally accepted for the measurement. And the reason why we are using SI as a standard, because SI offer the base units. So what is base unit? You see, base units are the fundamental measurement for quantities like length, mass, time, electrical current, etc. But how exactly? For example, you see, base unit refers to a fixed unit for a particular physical characteristics. For example, you see, in SI system, if you want to measure length, we are using what? Meter. And for mass, we are using kg. For time, we are using second. We are not using minute. We are not using hour. Here we are not using this grams or grains, and here we are not using or centimeter. But if I talk about this centimeter or kilometer, etc., all it belongs to metric. And even in this kg, grams, or if I use grains, all belongs to metric. Similarly, in time, meter, hour, second, we can say as a metric. And if you use metric, what will happen? We have n number of options. So there is a chance of confusion. So in the year, I think 90s, many countries, they held a meeting and they decided to use one base unit from that metric, and that is nothing but a SI. So SI is not a new. It's a drive from metric only. To avoid confusion, instead of using centimeter, kilometer, etc., for length we are using meter. For weight we are using kg. For time we are using second. For flow rate we are using meter cube per second. For velocity we are using this meter per second. Okay, I'll give you that conversion, don't worry. So just at this level, try to understand the concept of SI. So SI is what? Is a part of metric only. To avoid confusion, we are using the base unit from that to avoid confusion. So if all the companies are using this base units, SI, so there is no chance of confusion at the time of exchanging the data, because in actual practice, we are exchanging the data with the different companies, with the different, or if you talk about this building services, we are exchanging the information with the different services. Hope you're getting my point online.
Yes.
But you see, the problem is not totally solved, because still in actual practice, you'll find English system also. What is English system? We'll discuss next. You see, English system, also known as imperial, or we can call inch pound, IP. So English system, also known as imperial, or originated in UK and is used in US and few other countries, and is still in US or even in Gulf or in India. For practical point of view, I think in in practice, means not in design, or means in practice, we used to call feet. Feet is very commonly used even in construction, where we are calling 10 feet is bottom of slab, or this height of the door says 7 feet, or the width of the door is 3 feet. Commonly used. We are not considering as a standard, but still it is used in actual practice. So it's not possible to go for strictly SI, because we have one more problem using strictly SI. For example, if I use meter for the duct designing, what will happen? If you talk about the duct, you see we have this width. Consider this is a duct. Length, no doubt I can measure in meters. But this width and height is small. If I use in meter, what will happen? The width can be say 0.5 meter and the height can say 0.2 meter, etc. That will create confusion. Okay, so in actual practice for this ducting, width and height, we are using mm. For length, we can use meter. So the conclusion is, wherever possible, we'll use SI. And as per the product or as per the service or as per the condition requirement, we are allowed to use metric or English. So now in actual practice, most commonly for flow rate of air inside the duct, we are using CFM. CFM is the English system. If you talk about the metric unit for this discharge, it's a meter per second. But most commonly the term CFM, I think everyone aware of this, CFM, cubic feet per minute. Commonly use this term in actual practice. Even for this cooling effect, we are using ton. Ton is also not belongs to this metric. So don't get confused. Wherever possible, we are using SI because SI is an international system of units. But as per the market and 1 minute, as per the market or the service or the product requirement, we are allowed to use metric or English also. Okay, so you need to find out as per your consultant, as per your location, and accordingly you need to follow the units or as per the project requirement also. Sometimes your consultant may get the project in English system. Sometime your consultant may get the project in metric system from the main consultant. So you need to follow accordingly. Okay, so you see few examples given for English system. In English system, if you want to measure distance, one can use feet or inches. In SI, strictly meter. But in metric, we can use meter, mm, centimeter, etc. But in English system, we can use feet, inches, or combined feet and inches. And remember, do you know the difference between feet and the foot? Both are different or same?
Please, 1 foot singular.
Yes, exactly. Very good. So if other people participate don't know, please make a note. 1 foot means foot is a singular, feet is plural. Suppose 2 foot, I cannot say 2 foot. 1 foot I can say. 1 foot is correct. But 2 means feet. Okay, so singular is foot, plural is feet. So don't get confused. So distance we can use in feet or inches, or area, square feet or square inches. Flow rate of air, most commonly CFM, is a cubic feet per minute. Cubic feet is a volume. Volume with respect to time is a flow rate. We'll discuss more about this at the time of ducting. This level, just remember CFM, temperature degree Fahrenheit. Next. So you see what I explained the theory, you can read after this session. The origin and the use and the base unit, what I explained, I have given in theory also so that you can use as a reference. Consistency, accuracy, all this I have given. So accuracy, if you're looking for accuracy, you can expect in SI or in metric, because in English system, feet and inches means small components. If you measure in inches, you cannot maintain the accuracy. Small components like precision components, we are using in mm or in microns. Okay, so for that accuracy point of view, in industry, in this engineering side or medical side, you'll find this metric also, metric or say SI. But in construction, even this English system also commonly used. Okay, so can you share your experience online? Still you are using this English system in actual practice, or it's totally outdated in your consultant? I believe Mr. Akbar belongs to UAE, right? In UAE, we are using metric only, right? In Saudi also metric, but again, as per the project or as per the consultant or main consultant or location or type of project, you may find this mixed units or metric or English also. Okay, so be ready to use both the systems, because you cannot use or you cannot stick to only one. And now the question is, if you want to ready for both, what will happen? What problem will arise? Conversion, right? So the next topic is a conversion, and this also very, very important. So we'll try to visualize this units or this physical characteristics with the help of these conversions. So what is conversion? The unit have fixed numerical relationship to each other called equivalence or conversion. For example, 1 meter in terms of feet is 3.28 feet. And this will not change. It's a standard. If we talk about $1 in terms of INR, present I think 82 rupees. It may vary. That conversion may vary. That is also conversion, but not a fixed conversion. That is a variable conversion. But here the engineering, what we are learning is a fixed conversion. This will not change, and this is derived from the base, and the base of this distance, as per my knowledge, is light year, and still 1 meter piece, standard piece. When they drive, that standard piece is available in I think in New York Museum. So you'll find the history of all this, and that is not required, and nobody will ask in interview. If you want the history, you can watch some videos on the YouTube. In 5 years back, I used to provide some history also, but in present world, it's a world of AI. Nobody will ask these questions, and nobody have time to listen this. Okay, so in interview, you cannot expect this question from where you got this meter, from where you got this horsepower. We have a history of horsepower also. This horsepower based on the power of horse. So that much detail is not required. So directly I'll back to the topic. So we'll talk about the conversion. So in the conversion list, first you'll find length, nothing but the distance. So we'll try to visualize. But before this, quickly we'll do one small activity. Let me share this. Can you able to see the whiteboard online? So now what you do, just try to rearrange this in ascending order. I'm writing here, say kilometer, centimeter, say foot, inch, meter, millimeter, anything else? Can you arrange this in ascending order online? Small to big. First is what?
Millimeter. Millimeter.
Right. No confusion. Next.
Inch. Millimeter.
Inch.
Yes.
No. Centimeter.
A centimeter. Yeah.
Right. Centimeter. Then.
Inch.
Right. Perfect. Then.
Feet.
Excellent. Then.
Meter.
Right.
Kilometer.
Meter. Then kilometer.
Kilometer.
Okay. Now, can you visualize 1 mm? When you close your eyes, can you visualize 1 mm?
Yes. It's like a small dot.
Yeah, so everyone have the practical idea. 1 mm is what? It's small. You can find in the scale. So I think no need to explain this. Everyone can visualize. And this visualization is very, very important to avoid confusion at the time of conversion. If you have the practical idea, or if you can visualize, suppose if I say 1 meter, directly you're getting in the mind how 1 meter is so and so length. So you'll not get the confusion. Suppose if I say 1 feet, so 1 feet is less than the 1 meter. It's a one part out of this 3.28 part of this meter. So that experience you must develop, especially as a beginner. Experienced participant already aware of this, they can easily visualize that. But if you are a beginner, then this is very, very important. So you must develop this to avoid confusion at the time in actual practice, even in design or in installation. Both is important, and especially for estimation point of view. So mm, we can visualize centimeter. You see, this is one part of finger, then half of that approximately is 1 centimeter. Then inch, this one section of the finger is 1 inch. 1 foot. 1 foot means, for example, you can watch my video. Here you see this point and this point. You can take mid, from this mid up to this finger. You can approximately. Okay. Or else you can take the measurement, you can get some idea. Similarly, 1 meter. So 1 meter means from this one shoulder, if you just extend the hand up to that finger end, you can consider as 1 meter approximately. And in case of kilometer, when you travel with your bike or with your car, you have the idea. As a man, you have the idea. So because we are traveling now, so the kilometer from your home to this so and so X road. So you have some idea, right? So this practical experience is required. Okay. So now we'll talk about this conversion. I'm just going with some more detail because this topic is important, because till the end for all this modules, this will be used. So 1 meter in terms of what? Feet. You see 1 meter in terms of feet is 3.28 feet. It means in 1 meter, you'll find 1 feet, 2 feet, 3 feet, and 0.28 times. So this is 1 meter. So it means in that you'll find 3.28 times of feet. Okay. Similarly, 1 meter in terms of centimeter, 100 centimeter. So as an engineer, you must purchase a measurement tape also. You must carry that. Initially, if you're in design, that much is not required, but on site means always you need to carry this. So I recommend to purchase a measurement tape also if you're a beginner, so that and try to read that measurement and take the measurement and do some practice in home. So 1 meter equal to 100 centimeter equal to 1000 meter. So sorry, 1000 mm. Everyone know what is mm. Similarly, 1 meter in terms of inches, 39. How I got this? You see, 1 foot equal to 12 inches now. So 12 into what? Please just take out the calculator quickly. You are going to learn a new point. Take out the calculator and find out. 3.28 multiplied 12.
39.36.
Yeah, 39.36. But here I have taken 39. So remember, in HVAC or in plumbing or in firefighting, or in short, I can say application design. If you talk about designing, you'll find component designing and the system designing. Nothing but application. An application means I'm talking about, say, HVAC. HVAC is an application or a system. So remember, we are dealing in this training program, not only in this training, if you talk about the other services, in all this training for all the services, means I'm talking about MEP, we are talking about what? Component designing or the system designing. So remember, in system designing, round off is applicable. We don't require that much accuracy. We don't require 2-digit or 4-digit accuracy. In component designing, we require the accuracy in 2-digit, 4-digit or in microns. But here in system designing, we don't require that much accuracy. So round off is applicable. So remember the rule what we are following. After decimal, if you get the value above 0.5, we are taking the higher value. If you get the value below 0.5, we are taking the lower value. So 39.36 means I can round off to 39. For example, if I get 39.7, in that case, I'll round off to 40, right? So we are following this one. In manufacturing, again in HVAC manufacturing side, like manufacturing of 8 terminals or manufacturing of the components, they are following the precision of the 2 digit or more than that. But here I'm talking about the system designing. For example, if you are fabricating a duct or installing the duct, if the duct length increase to 1 or 2 mm, that will not affect to the system. But in case of component like a valve, like a valve, this this inverter side valve, so 1 or 2 mm also that affects. Okay, so don't get confused. Here I'm talking about the round off is applicable only for system designing, not for this component designing. So here 39 I can round off. So 1 meter in terms of meter is 1 meter in terms of inches is 39. And remember this 2 dash we are using to represent inches, and 1 dash this is for feet. This is used for representation. Next, similarly 1 foot in terms of inches, 12 inches. 1 inch exactly is 25.4 mm with 1 digit accuracy, but we are rounding off to again 25. Okay, similarly 1 foot in terms of mm, 304.8 exactly, but again round off to 300 because 25 into 12 is 300. And 1 yard in terms of feet is a 3 feet. And yard is what? Yard, do you know what is yard? In local language we used to call khadam. Okay, so 1 yard equal to 3 feet. So 3 feet is 1 khadam, means 1 yard. This is some important conversion related to what? Distance. Next, we have area. Please allow me some time for this topic because this is very important and very basic. This will help you even in designing also. So please don't ignore this. Next, area is what? 1 square meter. And you see, what we discussed just now is what length? Length is what? 0D or 1D?
0 to 1D.
So remember, point is 0D, length is 1D, area is 2D, volume is
3D.
Right, 3D. Okay, and you'll find this 4D, 5D, 6D, 7D, 8, 9, 7, 6, sorry, 7, 8, 9, 10, even 11. I think up to 11. D in BIM concept. Okay, so that is a different story. But in actual practice, if you talk about physics point of view, we have a 0D, 1D, 2D, and 3D. We don't have any component with the fourth dimension. In the mind science, you'll find some different dimensions, and in BIM concept, building information modeling, you'll find up to 7D in standard, but recently 3 more dimensions added. 9 means 1 minute, 5, 6, 7, 8, 9, 10. Yeah, 8, 9, 10. 3 more added. So in that BIM concept, 4D means 3D plus project scheduling, nothing but time. And similarly, this 5D is a 3D plus project estimation. Like this, they're considering as a different dimension, but it's not actual dimension. That terminology you will use in the BIM concept. But in physics, we have this 3D. So remember, area is what? 2D. So 1 square meter is what? 10.76 square feet. So how you can visualize this? Because as I said, now we are going to learn this in application side, not just theoretical. So 1 square meter in terms of square feet is what? 10.76. So how we can relate this? Let me give you. For example, consider this side is 1 meter. This is 1 meter. This is 1 meter length. Okay. In that, so 1 meter means how many feet? 3.28 feet. 3.28 feet. Okay. Suppose if I draw 1 feet, 2 feet, 3 feet. Okay. Similarly, this side, say 1 feet, 2 feet, 3 feet. Okay, and this side, say 0.25. So this is 1 square feet. Like this, you'll find 10.76 square feet of area. So this one box represents 1 square feet. Okay, roughly I'm just showing exactly if you measure. This last box is going to be small one. So just ignore this drawing proportion. We'll get 10 complete boxes and 0.76 box of square feet. Total 10.76 square feet in 1 square meter. Okay. Can you able to visualize this? Or say round off to 11, just for learning point of view. So in 1 square meter area is 2 dimensional. You'll get approximately 11 times of square feet area, because 1 square feet is what? 1 feet into 1 feet. So this is 1 feet, this is 1 feet, this is 1 square feet. Like this will fit 10.76 times of square feet. Right? Now, 1 square feet in terms of square meter. This point you can understand because this meter to feet I can show in graphical way. But in case of 1 square meter equal to, 1 square feet equal to 0.093 square meter. What it mean? How we can understand this? First of all, how we are getting the 0.093?
It's 1 by 10.76.
1 by mathematically 1 divided by 10.76, you'll get 0.093. But practically for understanding point of view, it means 9.3%. It means 1 square feet is 9.3% of 1 square meter. Means this box, or just for understanding point of view, you see 1 square feet is what in terms of square meter is 9.33%, because 1 is 100%. 0.1 is what? 10%. Similarly, 0.093 or 0.01 is what? 1%. So 0.09 is 9%. 0.093 means 9.3%. So 1 square feet in terms of square meter is 9.3%. For just understanding, because this visualization, this understanding is important, because all this theoretically already learned long back in school, in engineering, but here the practical understanding is important. Clear online? Next, similarly, 1 square feet in terms of square inches is 1 square inch, 144 square inch. Sorry for that. Once again, 1 square feet in terms of square inch is 144 square inch. And easily you can relate this. If you take, or if you want, you can practice this in AutoCAD also. I believe you already start AutoCAD. Yes, online. Do you know now how to start AutoCAD from the video course?
Yes, started.
Yeah, Mr. Ajay and Mr. Akbar.
Yeah, I also started.
So just parallelly work on that, because even as a design engineer, AutoCAD is required to extract the information, and for drafting, definitely it's required. So, Mr. Akbar, if you're not, if you don't know, just don't worry. At the end of the session, just remind me. I'll show you how to access this AutoCAD from the video, because AutoCAD and drafting we are offering is complementary. Directly, you can go to the website and access. I'll show you how. Okay, back to the topic. So in AutoCAD also, you can do this. You can practice this. What you do, draw a line of 1 feet. And this side also 1 feet, 1 feet and 1 feet, and complete the box. And take the offset of what? 1 feet, you'll find 12 inches. Na? So just take a offset of 1 inch and draw the lines. You'll get 12 lines on this side and 12 on this side. And if you count the boxes, you'll get total 144 box. It means in 1 square feet area, you'll find 144 times of square inch area. Right? Simple. Next, you see 1 square yard in terms of square feet. You can relate 1 yard equal to 3 na? So squaring on both sides. Here 1 square yard is 3 into 3 is 9, feet into feet, square feet. So again, if you take 1 yard into 1 yard, this is 1 yard and 1 yard, and 1 yard you have this 3 feet na? So you can draw this exactly. You'll get 9 boxes. So this is 1 box of 1 feet, so total 9 square. And generally in actual practice in local language we used to call gaz. A gaz means 100 gaz. Generally, when you purchase a land, we are considering this gaz, na? 100 gaz, ya 200 gaz, etc. Common units in actual practice. Next, so this is related to the area, and this is common for all the services. But now, if you talk about HVAC, we have this specific, this tonnage. Okay, and you must aware of this. May ask in interview also. Very basic and important, and we'll use at the time of calculation. Then everyone aware of this, not ton TR. I'm not talking about 1000 kg. I'm talking about TR, cooling effect. Nothing but the refrigeration effect. In the previous session, we already discussed. So 1 ton in terms of kilojoules, we discussed this 210 kilojoules per minute. No? Exactly, you will get 232 something, but round off to 210 kilojoules per minute in actual practice. Next, 1 ton in terms of kilowatt. This also, 3.5 kilowatt, and it's a mechanical, not electrical. And this is a fixed. This will not change. Electrical kilowatt will change as per the efficiency of the unit. That we'll discuss at the time of calculation. But this is a fixed mechanical kilowatt. In terms of BTU, 12,000 BT per hour. Okay, this also we discussed. This is important. Okay. And practically also you can relate now, already discussed. 12,000 BTU means if you want to get 12,000, or if you want to extract 12,000 BTU per hour, it means you need to use 1,000 kg of ice. And when it is melt, the cooling effect produced is at 12,000 BTU per hour. We discussed this, so you can able to visualize this, right? We discussed this topic at a unit of refrigeration. So these conversions are basic. Now further, if you talk about this tonnage, we have some more important. 1 ton in terms of flow rate is 400 CFM. And remember, CFM is what? Cubic feet per minute. Cubic feet means 1 cube is what? Consider a box with all the dimensions 1 feet. 1 feet, 1 feet, 1 feet. This volume is going to be 1 feet. 1 cubic feet. So this much of air volume if flowing inside the duct for 1 minute, I can say 1 cubic feet or per minute, 1 CFM. Similarly, if I say 400 CFM means 400 times of this volume is flowing inside a passage called duct in 1 minute. Okay, just to understand this unit. But here you see 1 ton in terms of CFM. How we can relate this? How 1 ton in terms of BTU per hour or kilowatt you can relate. How it's a heat. But this is a flow rate. How we can relate this?
400 CFM
Mhm.
air is flowing inside the building or inside a room. That much of air, cool air, get the effect of 1 ton is cooling effect.
Yes. So this is not the direct conversion. It means in order to get 1 ton of cooling effect in the space, the flow rate of air should be 400 cubic feet per minute. And this is not fixed. This is, we are considering standard.
Yes.
And this may vary in the calculation. You may get say 450 or you may get 350, depend as per the case. But in actual practice, we are considering this as standard or close to like thumb rule. So this, because this is not fixed, this is not same, but standard equipments or standard manufacturer follow the same. So for interview point of view, or we can say standard, we are considering as 1 TR equal to 400 CFR per minute. Means if you want to get 1 ton of cooling effect from split unit, standard split unit, the rate of the flow rate of that air which is throwing from that unit is 400 cubic feet per minute. This is standard. I can say this is standard, not the fix like 12,000 BTU per hour. So this you can consider standard, but at the time of calculation, you'll get the exact value with the tonnage when we deal with the load calculation. Next, similarly, and you see this is for air site. When we deal with the ducting in this air side, we are using this as a standard. Similarly, when we deal with the chill water site or chill water piping, we are considering this 1 TR equal to 2.4 GPM, gallons per minute. So before talking about this gallon, what we are using in this 2.4 is a US gallon, not UK. We are considering in India or in Gulf or in UK, sorry, in US, we are considering US standard. Okay, so remember this 2.4 GPM with respect to this US gallon, and 1 US gallon equal to 3.78 liters. Again, this is a fixed conversion in terms of US. So now what it means 2.4 gallons per minute? It means inside the coil, cooling coil, when the chill water flows, the rate of the chill water means the rate of discharge or the rate of flowing inside this tube in the cooling coil. It can be a black steel or it can be a copper. We'll discuss about the metal later. At this level, ignore this. So it's a cooling coil. So in this cooling coil, chill water is flowing in chill water system. Okay, what chill water system we'll discuss in chapter 5 and further in separate module. Separate part in design module. So it means 2.4 gallons per minute. It means a standard. And again, this is a standard. This may vary. And this 2.4 GPM based on the delta T as 10 degree Fahrenheit. Remember this point we'll use at the time of chill water pipe sizing. Based on this delta T10. And what is delta T? Forget about this at this level. Just I'm giving the clue. So based on this delta T10, we are considering 2.4 GPM as a standard to get 1 ton of cooling from this cooling coil. Just remember at this level. The detail about this we'll discuss in chill water pipe sizing. So this is related to the flow rate of water inside the tube, and this we are considering standard 2.4 gallons per minute, and this gallon is a US gallon, not UK. And if you talk about UK gallon, we have 1 UK gallon equal to 4.5 liters. Okay, so if you're working in UK, you can use this, but rest of the areas one can use this as a standard 3.78. Next, similarly, 1 CFM. CFM is what? Cubic feet per minute. In terms of cubic meter per hour, CMH is 1.7. Okay, so this also will use at the time of air side. This is for water side, this is air side, and this also for air side. So about this 1.7 CMH also, when we talk about exhaust system, I'll give you the clear idea. At this level, it's too early to discuss. But just remember, CFM is a cubic feet per minute and CMH is a cubic meter per hour. Here feet, here meter, here minute, here hour. And what do you think? The CMH is what, SI or metric? Metric. Because in SI we are using second. Meter is okay, but hour we are not using in metric. We are using second. So each hour means is a metric. So SI means you can consider meter cube per second. This is strictly SI for flow rate. And the CFM is English. And this we can call as a metric. Okay, so you must know, you must be aware of all this. Next, this is related to the tonnage. Now the question is, you see, first we got the idea, the measurement systems like English, metric, SI, etc. And in actual practice, we are using mixed units, so conversion is required. So up to this, there is no confusion. But now the question is how to use this conversion. People getting confusion in this using the conversion. For example, assume that I'm interested to change this 90 meter in terms of feet. So which conversion will use?
19 to 3.8.
So first of all, we have conversion 1 meter equal to 3.28
Wait.
feet to 3.28 feet. Okay, assume that you already memorized this. Now you can use. But again, at the time of using, the people get confused whether to multiply or to divide. So 90 into 3.28 or 90 divided by 3.8? Multiply, no? So the answer is correct. Multiply is correct answer. But on what basis? How we can say that? You see, we have one more conversion. 1 feet in terms of meter, we have 0.3 meters. Suppose instead of this conversion, if I use this conversion, then you'll get the confusion, na? When to multiply and when to divide, right? Practically, if you think, you can take the decision, because this meter is a higher unit and feet is a smaller unit, and when the unit decreases, the value must increase, right? Remember this rule. Whenever the unit decreases, the value must increase, and when the unit increases, the value must decrease, right? Agree with this? So you need to follow this rule. So remember, whenever I'm writing here, you can copy. Whenever when unit increases, value must decrease. So what we'll do? You are going to divide or multiply? Divide, na? For example, you see 90 meter in terms of feet. You are going to multiply. For example, say 100 feet in terms of meter. So you see unit in this feet to meter. So unit increases, so value must decrease. So what we'll do? 100 divided by 3.8. And similarly, when the unit decreases, the value will increase. You need to multiply. Sorry for this, the pen is not working properly. So whenever you're doing conversion, wait for 2 seconds and think what you are going to get. Means you are going to increase the unit or decreasing the unit. Increasing the unit means use divide. Decreasing the unit, then multiply. Because decreasing unit, the value must increase now. Means the magnitude must increase when the unit decreases. But here one more condition. But till this point, any confusion?
Yes, clear.
No confusion, no? But now the condition is this rule is applicable only when the conversion value is greater than 1. For example, we have this 2 conversion. 1 meter equal to 3.28 feet. Similarly, we have 1 feet equal to 0.3 meter. So 1 meter equal to 3.8, 3.8 is greater than 1, na? I can apply this rule. But in case if I'm using this conversion, then the case is going to be reversed. For example, 100 multiply with 0.3. The result will more than 100 or less than 100?
Less than.
You'll get 30, na? But you see, but common sense point of view, when you multiply something means the value will increase only when the value when the factor more than 1. If it is less than 1, the value will decrease, right? So be careful when you're using conversion value greater than 1, follow this rule, or else this divide will multiply and this multiply will change to divide. Just spend some time. If you're a beginner, just spend some time and follow all this to avoid confusion, and initially take the decision consciously and just develop the experience, and with the experience you can able to handle in actual practice for design, for installation, and especially for estimation, metal takeoff. Next, you see I have given some common conversion which is used in HVAC. At least you need to memorize this. What I've given the notes as well as this in the table. Some more conversions we'll use at the time of ducting, piping, pump selection, fan selection, etc. Okay. At this level, what I explain is what the units, importance of units, system of measurements, conversion, and the rule for conversion with some basic conversion. So you need to memorize. We'll use in this training program at the time of other parts of this designing. Okay.